Tangent line intersects a circle exactly one point called the point of tangency. So in this picture here, you've got, this is your tangent line, right? It touches the circle at just the one point, point A. That is considered your point of tangency. Okay, so that's obviously where the line touches the circle. A line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. What does perpendicular mean? Crossing, what kind of angles does it make when it crosses? A right angle, exactly. So in order to be a tangent line, it has to make a 90-degree angle at the point where it touches the edge of the circle. It also has to create a radius, right? So a radius is from the center to the edge of the circle, and there are an infinite number of radii in this picture. You can draw a radius anywhere as long as it's from the center to the edge. Okay, so for numbers 1 and 2, we're just going to determine if, bless you, oh, sorry, I thought you were about to sneeze. We're going to determine if AB is tangent to the circle or not tangent to the circle. So in number 1, you've got, here's your triangle. Okay, first of all, where does your 90-degree angle go? Where would it go? At which point? Point A, B, or C, or P, sorry. At point A. Okay, so if this is a tangent line, A would be a 90-degree angle. Now, if this is a right triangle, which formula are you allowed to use to solve for sides of a right triangle? Yeah, good job. The only one that's important is the C. Which one has to be the C? What number do I always put it as the C squared value?
Oh, hypotenuse.
Yeah, the hypotenuse, the one that is across from the 90. Okay, it has to be across from the 90. All right, so in my picture here, which one is my C squared value? 17, perfect. All right, so all we have to do is plug in our numbers, and we're gonna double check to see if they work or if they don't work. If they do work, if this makes a true statement when I plug them in, that means the lines are tangent. If it does not make a true statement, that means that the lines are not tangent. Okay, so for my two numbers, I just plug in 8 and 15. And I plug in 17 squared for my C value. And then all I'm doing is plugging in and seeing if it works. So 8 squared is 64. 15 squared is 225. 17 squared is 289. What should I do next? Add 64 and 225. What do you get? You get 289. Huh? Try again. Okay. Is this a true statement? Yes. So my answer is that yes, AB is tangent to the circle. That's my answer. Is tangent. Okay, that was it. That was the whole problem. Easy peasy, right? Yeah. Okay. Let's look at number 2. All right. Still a right triangle, so it's still going to be A squared plus B squared equals C squared. Again, the only thing that's important is my C squared value. Where does your 90-degree angle go? At A. Okay. Which side is my C value? Is it? That's 5. From what letter to what letter is the hypotenuse? Okay, from B to P, but we only know that from B to the edge is 5, right? So that's from here to here. How do I know what from the edge to the center is? Why is it 11? Good. These are just different radii, right? From the edge to the center is a radius. There's an infinite number of them. Anyone that goes from the center to the edge has to be the same. So since this one's 11, that means this piece is also 11. So what does that mean my full length is of the entire side? 16. Good. I just add the two together. And then what do I put for my A and my B? 14 and 11 does not matter which order you put them in. Okay, so take a sec and check. Let's see if that gives us a tangent line or a not tangent line. Because it's a radius. So anything from the edge of the circle to the center has to be the same. There's already another 11 down at the bottom there. That's a radius too. Anything that goes from the center to the edge then has to be an 11. Good question. Okay. Raise your hand if you think AB is tangent. Yes, the answer is yes. Raise your hand if you think the answer is no, it's not tangent. Yay, good job. Beautiful. Okay, so when it doesn't work out, not tangent. Okay, that was it. What do you think? Feel okay? All right, we're gonna do like one or two of the unknown ones where we find the length ourselves, and then we'll skip on over to the back, okay? So in 3 through 6, this time I'm telling you that piece segment JK is tangent to the circle. So you're finding the length of X. So obviously what that means is it should be a right triangle, and you are just then solving for the unknown side length. So in number 3, where does your right angle go? At J. Okay. What number are we going to put in for our C squared value? X. That's our hypotenuse. It's the longest side. And then our A and our B are our other two sides, which are 7 and 19. Can you finish that problem? Take a second, finish it. If you haven't already. Oh, I frozen the screen. Sorry. That's lame. Did you get the same thing as me though? About 20.2. Does everybody remember how to do square root on their calculator? Right there? Cool beans. All right. Is this like the easiest thing ever or what? Yeah. We're going to set up the equation for like 4 or 5, then we're going to flip it over. Okay. We're not going to do the whole thing. All right. Any questions on that one? We feel cool. We feel golden. We're amazing, right? Okay. Number 4. So again, like I said, I'm just going to set it up. We're not going to worry about actually doing it. But in number 4, where does your right angle go? At J. All right. Which side length is your C squared value from what letter to what letter? From K to L is your C squared value. Now, what is the length of that full side? How'd you get 18, Evelyn? Yeah, this piece is also 11 because these are both a radii of the circle. So this is also 11. The full length is 18. So let's just write the equation. What would my equation be for this problem? Beautiful. Okay, do you want to do it or can we just leave it there and move on? We okay? Yes. All right, then let's move on to the other one. I'll just tell you what the answer is. The answer to that one was 14.2. So if you want to go back through and try it, you're welcome to. Okay. All right. Number 5. Okay. Where does your 90-degree angle go? At J. All right. Now, which side is your C squared? K to L. Yeah, the X is just from K to the edge. If it was the full length, they would draw like kind of like the bars here, like on this one, they would show you that it's the whole length. But if they don't have the bars, you can assume it's just the one piece of it. Okay, now, what is the full length of K to L? Yeah, 10 plus X or X plus 10, right? Because this piece is a radius. Now, here's what's going to happen in a second. If we use X plus 10 and we go to square it, what are we going to end up with? What kind of equation? X plus 10 times X plus 10. You're going to have to do FOIL. Right? You're going to have to do, and then some factoring. Do you want to do that? Would you like to do it an easier way? Okay, let's do it like this. You can still do it that way, okay? If you want to factor, like, I am not going to stop you. Go for it. But here's what I'm going to suggest. Let's pretend for a second, if you knew that the whole length was like 30, what would the X value be worth? How'd you get that? You subtract the piece from the whole thing. So why don't we just call the whole side length Y, solve for it, and then just subtract 10. That'll give me what's left over. And that way your life is just a little bit easier. So you've got 10 squared plus 24 squared equals Y squared. And we can do it that way instead. So that's 100 plus 576, which is 676. And then to get the Y by itself, I square root. I don't know what that number is. You want to square root that for me? 26, thank you. Okay, so if the full length of this whole thing is 26, what is your X value worth? 16, good. So your X value, or sorry, your X value, oops, is you take your 26 and subtract your 10. That's like the hardest one right there. So if you can do that one, you can do the rest. Okay. Questions on any of those? We feel great with tangents. It's the easiest thing ever. Okay. Let's just take a look at these two properties real quick and then we'll flip it over. Here are the only two properties. It says if two segments from the same external point are tangent to a circle, then they are congruent. So if you have two lines that are tangent, right, they make 90-degree angles and they meet up at the same point, that means this segment AB is congruent to this segment CB. And if you have two equations there, like that, what would you do with those two equations? You would just set them equal to each other exactly. And then you'd solve. Okay, so if you've got two pieces that are the same, that just means you take them and you set them equal to each other. The last property of tangent lines is if you have a polygon that is circumscribed, that means on the outside around a circle, then all of its sides are tangent. So using that same idea, yes. Oh, I just made up a number. I was just like saying if there were two equations here, you would just set them equal. I just was making something up. Okay, so if you've got your polygon circumscribed around all of the sides or tangents, so what that means is this, just like with here, the two lines that meet up at the same point are going to be congruent to each other. So BD, for example, is going to be congruent to BE. Those two pieces will be the same. Which piece is going to be the same as EC? CF. These two, they need to meet up at the same point. So these two pieces will be the same. Which one's going to be the same as DA? AF, yeah, good. These ones will be the same. So obviously, if you know one of them, automatically you'll know what the other one is because it'll be exactly the same thing. And that is tangent lines for you. So tangents are easy because they just make right triangles, and you can solve a right triangle using a squared plus b squared equals c squared. Any questions on tangent lines? Show me with your fingers how do you feel on a scale of 1 to 5. 5 is like, yo, I got this. I can ace this section. Okay. All right. Thank you. Flip to the back. Do a few on the back, and then we're out of here. We're done. Last section. Okay. And also, I'm sorry, because I know this is boring, so I apologize. But this is the last time we have to do this. All right. The last section is called arc length and sector area. So we're going to start with arc length. So recall, an arc is any of the following three figures. It could be a minor arc, a major arc, or a semicircle, right? Half of it, or less than half, or more than half. The length of an arc is the circular distance around the arc. So before we have talked about like the measure in degrees, now we're talking about the distance around it. So think about it. I like to think about it like as a piece of pizza. If you think about your pizza, you can figure out how long like the crust is of the pizza. That is what arc length is. The equation for arc length is given to us right here. So I'm going to highlight this. This is our equation. And our equation is to find the arc length, we take 2 times pi times r, where r is our radius, and we multiply that times x over 360. X is going to be the degree measure of the central angle. So it's how many degrees it is out of 360. And then we multiply it by 2 pi r. Does anybody remember what 2 pi r gives you? Just what that little formula is by itself? Circle. Not the area. What's that called? Not perimeter. Circumference, yeah. So 2 pi r is literally circumference of the circle times however many degrees you have out of 360 is how we look at it, right? So it's not a hard section, but it's definitely like a calculator heavy section when we go to plug these numbers in. So I'm gonna grab my calculator real quick. Okay, so if we take a look at the first one, it says determine the measure of the arc length of arc AB. Okay, so we're trying to figure out the arc length. Okay, so we don't know what that is, so I'm going to put L there for my length. Equals. Now, personally, here's why did this freeze on me? Personally, how I like to write it when I go to do. All right, 1 second. Okay. When I go to write it, I like to put everything on the top of the equation and then just put the 360 at the bottom of the equation. So when I do it, I'll go like this. I go 2 times pi times my radius. What's your radius in this problem? 8 times X is your degree measure. What's your degree? 60 degrees all over 360 degrees. Okay, now we're gonna do it in exact form, meaning I'm not gonna actually push the pi button. We're just gonna push the numbers and nothing else. Okay, so multiply all the numbers on the top and then tell me what that is. 960. I mean, I'm gonna trust you. Okay. So your final real length is 960 pi over 360, but we can reduce that. So what can you divide both of those numbers by? You can definitely divide them both by 10, right? So I can just cancel the zeros. Ding, gone. Now you're at 96 over 36. You can divide them both by what? 6. You can divide both by 12. 60. No, not 60. It was 96. I think 12. Yep. If you divide them both by 12, you get 8 pi over 3. So that would be your exact answer. So it depends. I don't know what the test is going to ask you. If it's going to ask you for an exact number or if it's going to ask you for a decimal. If it asks you for exact, that means leave the pi symbol. Okay, this would be your exact length. But if it asks you to round it, go ahead and put that into your calculator and let's round it. Let's see what that gives us. And actually use the pi button. Do like to the 10th. What do you get? About 8.4. And because we're talking about length, we're talking about distance. So our answer should be in centimeters because we're talking about a length. And so actually I should put centimeters here as well. Okay. So if I ask you for it as exact, that means leave the pi symbol. If I ask you to round it, that means physically actually multiply it times the pi. Okay, how do you feel? You feel great? You feel wonderful? You feel amazing? Okay, why don't you try that next one right there? To the right of it. The measure of arc RS. So the length of RS. Just like how we did, try to do an exact and do a rounded. And when you do an exact, reduce it as small as you can. I should have done one again. Okay. I realized I probably should have done this one with you. I apologize. After we wrote it. So here's the deal with this one. This time they're telling you, bless you, the length is 44. That's the length. You've got 2 times pi times your radius, and you're trying to figure out the measure of your arc measure, right? So you're trying to figure out what the degree is of this arc, RS. I told you the length, so that goes over here is the 44. And then you got divided by 360. This is an algebra problem where essentially you're trying to get x by itself. So everything that's not an x has to get moved over to the other side. Now, what should be the first thing I move? I want to get the x by itself, so everything else has got to go the other side to the left. Perfect. So we'll start first by multiplying by 360. We'll get rid of that fraction. Good. That's going to be a big number. I should have written smaller. 1, 5, 8, 4. Okay, great. Now, on the right side, you're left with 2 times pi times 15.28 times x. Which 2 numbers you just multiply together right now? Yeah, and so multiply the 2 and the 15.28. We always try to do the pi like at the end, because if you leave it, then you can leave your answer more exact, okay? So we're just going to multiply the 15.28 and the 2 to start. So that is 30.56, and you're left with pi and x. Okay, so we just kind of like combine some like terms there. Now, again, you're still trying to get the x by itself. So what should I move over to the other side? Okay, by doing what? Dividing it. Good. This is multiplication. So divide by 30.56 on both sides. 840. 30.56. Okay, I'm gonna round because that's a crazy number. Because this is multiplication. All of these are getting multiplied together. So to undo multiplication, I have to divide them. If it was adding them, then it'd be fine. But since I'm multiplying, I have to divide them. Good question. Okay, what is my last step? Divide by pi. Yes. And so this is why we always kind of wait till the end, because that way you get to keep your answer a little more exact until you get to the very end here. So when you go to put this in your calculator, literally push that decimal divided by, put the pi button. What do you get for angle X? About 165. And we're talking about an angle, so you need degrees. So that one is like an algebra type problem. Okay, why don't we do one more like that, another algebra problem one, and then we'll go on to the last section. So I want you to do the one right underneath. Now you're going to solve for, this time you're solving for the radius. So you're solving for the R over here. Okay, so I'm going to give you a couple minutes. I want you to try this one, and then I want you to check with the people at your table. Okay, so I'll give you like 3 minutes. Okay. The one right underneath, you're solving for the radius this time. So I give you the degree, right? I give you this, the 150, that's your degree measure, that's your X. You don't know what your radius is, that's what you're looking for, that's your R. And this piece right here, the 10.5, that is your arc length. Okay, so you're just solving for an R. So again, it's going to be an algebra problem where you have to get everything over to the other side. Okay, so I'll give you guys a couple minutes to try that one.
No, because you still have to set this equal to your arc length, which is. Yeah, but that's different. Multiply first, yeah, so get rid of the 360 first.
Good job. Check people at your table, see if you got the same number. English. Good setup so far. Get rid of that 360 first. Little friend. That seems very big. Does that not seem very big to you?
I think, did you subtract friend division?
Oh.
Oh. Good.
Yay! Good. Good, good. Check with each other. You're like 1 more second here.
Well, it's okay to be off by like a few decibels.
Yes, 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 yes. But you shouldn't be off by a lot more than that. Okay, did you get about 4? And actually, what is Mr. Massa missing? Oh, not to agree, because we're talking about a radius from the length of something. Yeah, I need the feet in there, so this would actually be considered wrong. Gosh, Mr. Masso. So I multiply both sides by 360. And then I multiplied 2 times 150, got 300. That's why I divided by 300 on both sides. And division, not subtraction. And then I divided by pi at the very end. We got 4.0. Cool. Okay, so it's just a little bit of like manipulation with your algebra problems. And you are definitely going to see one like that on your final exam, like for sure. Absolutely. Okay. One more section, then we're done. I have to check and see because truthfully, I don't know what they give you on the exam yet because I actually haven't looked at it yet. So I know they give you the formulas for like volume and surface area, but I don't remember everything else. So I cannot see the test. And it's a brand new this year. So I'm also kind of guessing to the best of my ability along with you guys. You'll be fine though. I'm really not worried about it. Okay, we're gonna do 2 more problems and we're finished. We're complete. Does anybody have any questions on that one? If you would like for this one right here, right next to it, you don't have to do it, but if you want, the answer to this one is 5.9. So if you want to go through and you want to try that one on your own, just to check it like later, you are welcome to do that. You don't have to, but that's the answer to that one if you want to check it. Okay. You know what's really funny is the pictures didn't show up on this too, did they? Was there a picture down there? That would make those 2 problems really. Oh no, wait, there's not supposed to be one. Never mind. I lied. Okay, ignore me. I'm losing it. All right, we're gonna do one of these and one of these. Okay. So we'll do 2 on the right. All right, now this time we are talking about area of a sector. So again, if you think about a pizza, a sector of a circle is a portion of the circle that's comprised of an arc and its 2 radii. In other words, if you think about a slice of pizza, it's like the full amount of pizza that you're actually eating is the sector area. Okay. Whereas the arc length is the crust, the part on the outside. So in this second problem here, it says find the area of the shaded sector. The equation is almost the same. The only difference this time is instead of it being 2 pi r, it's pi r squared. What does pi r squared? What's the equation of that? Isn't that right? If 2 pi r was the circumference, pi r squared is probably the area of a circle. Yeah, pi r squared. So it's almost the same thing. It's just this part here that changes. So in the second problem, you're trying to find the area of the sector. You need to know the radius and you need to know the x value. What is the radius in this problem? That's what? The radius of this one. So I tell you that RS is 43. What would the radius be? How'd you get that? Divide it by 2. Good. So the radius is half of this number. So my radius is 21.5. Good. Now we also need the x, which is my degrees of the central angle. Now, this one, I tell you, this one that's unshaded, this is 17 degrees. What does that mean this one over here that's also unshaded is? 17 degrees. I want the degree measure, though, of the ones that are shaded. How do I figure that out? Subtract 17 from 180. That'll give me one of them. Yeah. And I can do it that way. So you get, this is 163, this arc degree measure. What does that mean this one is? It's also 163. In total, what's your total shaded area? What is the total degree measure of your shaded area? 326 degrees. So our x value is going to be 326 degrees. So now all I have to do is take those numbers and plug them into the equation. So to find the area of the sector, and we usually just use S per sector. Area of the sector, we do pi times radius squared, so 21.5 squared, times my x value is my measure of my central angle, and our central angle is 326 all over 360. Okay, so take a second, multiply that, and let's leave it first as an exact number. You don't have to reduce it because it's going to be a crazy number. And let's also round it to the nearest 10th as well. So those are two numbers you got. So either you can do, if you do this whole piece right here, right, you do 21.5 squared times 326, and then whatever that number is divided by 360. That gives you this first one here, 418.6 pi, or you actually multiply the 418.6 times pi, and you get 1,315.1, and it is area, so it is going to be in meters squared. Either of those are fine. If they ask you to leave it in terms of pi, that means they want you to keep the pi symbol. If they ask you to do it rounded, that means you do it like this over here. Okay. Questions, comments, concerns? All right. I really need to pee, so I'm gonna take 1 second. I want you guys to do this bottom problem right here while I go, okay? And then I'll be right back. We'll try it out.